Welcome to a virtual tour through one of BioConstruct's biogas plants. Controlled fermentation of biomass in biogas plants produces a gas that can be used to produce electric or thermal energy on account of its high percentage of methane. The raw materials used in biogas plants, also known as substrates, are often liquid manure, agricultural products and agro-industrial waste. The following animation will demonstrate how electricity and heat are produced from these substrates in biogas plants made by BioConstruct. This biogas plant uses ensilaged maize as one of its renewable raw materials. With the aid of a wheel loader, the maize is tipped into a cement storage bin, which needs filling up approximately once a day. Silo maize is rich in energy and, on account of its high degree of reduction, very well suited for use in biogas plants. This storage bin is equipped with a hydraulic floor discharger that continuously feeds the maize onto a conveyor belt. A scale under the conveyor belt registers the weight of the maize silage. Liquid manure is the most important basic substrate used in this biogas plant. After a short interim storage in the pigsties, it is pumped through pipes directly into the blending pump beside the maize conveyor belt. At the same time, the maize falls off the conveyor belt into this apparatus, which is equipped with two mixing rollers. In this way, the maize silage is mixed before fermentation. With this technology, it is possible to supply several fermentation tanks, also known as fermenters, with fresh substrates, even if they are not close together. Liquid waste from the food industry is the third substrate used in this plant. As the availability of such waste varies considerably, a large storage pit should be installed. Integrating this into a hall serves to minimize smells and to help prevent epidemics. Now the liquid waste is heated with hot water to 70 degrees centigrade in a tubular heat exchanger using a countercurrent process. After heating for 1 hour, the hydrogenization of the substrates is complete, so that they can now also be poured into the fermenters. Here is where the biogas is formed. The substrates are continuously stirred in order to prevent layers of material forming at the top or on the bottom. A hot water wall heater heats the substrate to between 35 and 55 degrees centigrade in order to accelerate the formation of methane. On average, the substrate is in the fermenter for a period of around 30 days, before it is filled into another fermenter for a further 30 days to complete the gas formation process. When fermentation is complete, the thin liquid substrate is pumped into two reinforced concrete tanks, where it is stored until it can be brought out onto the fields. If the fermenters are filled regularly with biomass, are airtight, heated and regularly stirred, the biogas forms within a matter of days. The formation of gas is a complex and delicate process. The organic fats or carbohydrates contained in the substrates are digested by various kinds of bacteria, and this is the starting point for the development of the gas. If the contents are continually stirred, the gas rises slowly to the top of the container. It consists of approximately 50 to 70% methane, coloured green here, and also carbon dioxide, water vapour, hydrogen and hydrogen sulfide. As water vapour and hydrogen sulfide are problematic for the utilisation of the gas later, it is necessary to treat the biogas now. gas is first freed from water vapour, coloured blue here. The condensation water is collected in a condensation shaft and pumped out. The aggressive trace gas hydrogen sulfide is now extracted from the biogas in a biological desulfurization plant. By introducing air into the container, certain bacteria cultures are able to establish colonies on the chain. Here they decompose hydrogen sulfide into harmless sulfur and water. The almost unpressurized biogas is then fed into a compressor, where it is brought up to the 70 millibar pressure later required for burning. In order to completely condense any remaining water vapour and to free the biogas from any suspended matter or silicates, the biogas is subjected to a washing and drying process. This is carried out with the vapour at almost freezing point so that the gas is cooled down to a temperature of under 5 degrees centigrade. In order to control the purification of the gas, the biogas is constantly tested with an online measuring system, which records the amounts of methane, hydrogen sulfide, carbon dioxide and oxygen. This guarantees a high degree of efficiency and security. In case of any overproduction of biogas, it is necessary to operate a gas flare, for unburned methane that escapes into the atmosphere is harmful for the climate. The biogas from this biogas plant enables 2-block heating and generating power stations to run and be CO2 neutral. To annually process biogas from 15,000 tonnes of biomass, this plant must produce a total of 500 kilowatts of electricity. Due to the optimal gas processing, the engines can run round the clock for several years with only a minimum of maintenance costs. Up to 30% of the waste heat from the cooling water of the engines is used for the heat exchanger and the fermenter, so that no additional heat is required. The remaining heat can also be used profitably to heat industrial plants, houses or swimming pools. The electric power generated by the generator of the block heating and generating plant is converted to the mains voltage level in the transformer. Then the electricity can be fed into the grid and meets the annual requirements of around 1,000 households. A biogas plant with an annual operating capacity of 15,000 tonnes a year requires 3 to 5 hours work daily. In order to keep the amount of work down to a minimum, we particularly recommend the use of an effective measurement and control technology from BioConstruct. Thanks to a safe exchange of data, it is also possible for someone who is not on the spot to monitor and control the unit. Should it be necessary, either the operator at home or the BioConstruct service team can intervene in processes in the biogas plant. For example, the agitators can be switched on and off. The levels of the containers and the pits can be checked, or the solid supply equipment can be monitored. Information about malfunctions or an expensive standstill of the block heating and generating plant can be registered on BioConstruct's service computer or on the operator's mobile phone. This guarantees a short reaction time when anything unexpected happens and a reliable service by the BioConstruct Customer Support Office. Biogas plants produce high-quality fertilizer as well as electricity and heat. The nutrients contained in the substrates are retained and are more easily available to the plants, as the flow power of the liquid manure and its ammonia content have increased due to fermentation. The unpleasant smell of the liquid manure and organic waste has disappeared as the organic acids have decomposed. A biogas plant is therefore useful for both you and your neighbours. Why don't you also profit by using the smart, environmental-friendly biogas technology in BioConstruct's modern plants?